everyone, and welcome back to week 3 of MakerGirl online curriculum. My name is Mary, and I'm going to be walking you through this week's theme, chemistry. Please make sure you have the Creating with Chemistry worksheet in front of you during this session. We'll be walking through it throughout the entire lesson. To start, what do you think STEM stands for? In the first section of your worksheet, it has the letters S, T, E, and M. Take a second to fill in what you think STEM stands for. All right, let's check that you have the correct answers. S stands for science, T stands for technology, E stands for engineering, and M stands for math. Make sure you have science, technology, engineering, and math under your STEM section. Now, our theme this week is chemistry, but what is chemistry? Well, chemistry is the study of matter and the way different parts of matter are combined and separated. But what even is matter? Well, matter is anything that has mass and takes up space. Think of everything around you. Everything around you is a part of matter. Now, matter can be in 3 different phases. Those 3 phases are solid, liquid, and gas. Now, let's take the molecule water, for example, and show you the different phases it could be in. If you can think of water in a solid form, we can think of ice cubes. If we can think of water in a liquid form, it would be a glass of water or what we drink every day. If we think of water in a gas form, we can think of maybe making pasta for dinner and having to boil a pot of water first. When the water starts to boil, we see steam come off of that pot. That steam is water in its gas phase. So to think about 3D printing and our material, PLA plastic, and what phases those machines are in while it's printing, we can think of what phase do you think the plastic is in while the machine is printing versus the phase the plastic is in when our object is finished. Now I'm going to skip ahead a couple slides just to show you the back part of our printer, right here in the upper left-hand corner. There's a spool of plastic on the back. That's bright pink plastic that's being fed in to our nozzle that you can see up here that is printing out an object. Now our printer heads and nozzles get super hot to melt the plastic. When it melts the plastic, it's able to be more malleable and form into our shapes, layer by layer. When our print is complete, it looks like this little robot down in the bottom right-hand corner. It is a solid piece of material. Now, because we are melting the plastic, we are making the plastic seem a little bit more malleable. So take a second and fill in what you think our plastic phase is when we're printing versus when the object is finished. Awesome, all filled in? Great. Now let's move on to brainstorming our designs. If you flip over to the next sheet, it'll say brainstorming. Take some time to think about what you would want to design today. Draw out your ideas on that piece of paper in front of you. You can make it chemistry related, so making a molecule, maybe a beaker, and start brainstorming. Really think about what you want to create. And now also think about what different shapes you can use. I would pause the video right here, take a few minutes, and draw out what you want to create today. Think of maybe identifying squares, cylinders, different shapes that you can think of that you can use in Tinkercad on the next step. Are you done brainstorming and ready to move on? Great! Step 2 is designing on Tinkercad. Head over to tinkercad.com and with your parents' permission, make an account and then create a new design, a 3D design. When you do that, you'll come here and you'll see this blue work plane in front of you. You'll also see some shapes on the right-hand side. These shapes are what I was trying to think of when we were brainstorming. We have some boxes, some cylinders, a scribble tool where you can make your own if you can't find the shape that suits you. To use Tinkercad, you'll be dragging and dropping the shapes. You'll be dragging and dropping the shapes from the right-hand side and bringing them onto your work plane, making sure that all the items connect and that there's no space in between those items. If you have never used Tinkercad before and need some additional help, please click on the work plane and it will send you to our Tinkercad video. Here, it'll show you a more in-depth walkthrough about Tinkercad. Just for an overall example, you can drag and drop the shapes, use the different boxes, the white and black boxes around the shape to extend the sides. You can shorten and grow the shape by finding the white box on top, and you can stack shapes by finding the black triangle on top and pulling up or down. If you need more help again, please head to our Tinkercad video where our friend Grace gives a great in-depth conversation on how to use it. And don't worry about the colors of the shapes. Now they have set colors or you can change the colors, but all of our printers print in one color, so there's no need to change them. Again, if you need help on Tinkercad, click the little Tinkercad logo here and it will take you to our video where it's a more in-depth walkthrough. Pause the video now and take the time to create your design on Tinkercad. Did you finish your design? That's great. Now I just want to walk you through again how 3D printing works. Now, after you design your shape on Tinkercad, I can download it onto my computer on Curie, which helps me change the size and how much time it's going to take to print. I then upload that piece onto an SD card and put the SD card into our printers and select your print. Now, like I was saying before, our plastic is threaded through the back of the printer into our nozzle head, where it is heated up to a point where it can be melted and print layer by layer, like is happening up here. When you first have your picture being uploaded onto our printers, you may think that your design doesn't look anything like it did on Tinkercad, but that is because it's printing layer by layer. It might take until the end of the design, which can take up to 30 to 45 minutes in MakerGirl's case, for it to look like how you had it on Tinkercad. Now that we learned 3D printing and got to design our own 3D print, we wanted to teach you about a famous woman in STEM, more specifically a famous woman in chemistry, Marie Curie. Marie discovered the elements polonium and radium during her research in the study of radiation. Because of these elements being found, she was the first woman to win a Nobel Prize and the first person to win the award twice. Please take a moment on your worksheet to fill out the information that we ask about Marie. Now we're going to move on to the activity side of the worksheet. It is called solution or mixture. To give some context, a solution is a type of combination studied in chemistry that cannot be separated. It's also a type of mixture. So a mixture is a combination where different things take up the same space. For example, we can think of salads versus salt and water. When you add salt to water, you can mix it up and you almost can never see the salt again, versus a salad where you can see all of its different parts. In a salad, we can pick apart the lettuce and the vegetables and put them back into the piles in which they were originally. But with salt and water, we can't physically take the salt out of the water once they're mixed. Think of the ocean. You almost forget that salt's in there until it hits you with a splash of water in the face and you can taste it. Now we're going to do an activity. We have 5 items in front of us: soda, trail mix, Kool-Aid, pizza, and apple juice. If you think one of them is a solution, circle it. If you think it's a mixture and not a solution, put an X through it. Now take a few minutes to do that, and once you have the answers, you can play the video again. Which pictures did you circle? The ones you should have circled were soda, Kool-Aid, and apple juice. Now, why are these solutions? Well, these are considered solutions because once they're mixed together, we cannot separate it from the other as is. The Kool-Aid is made up of water and sugar / the Kool-Aid mixture, and when we mix it all together, we can't physically take the powder back out of the water. They are now a solution. Which pictures did you put an X through? You should have put an X through the trail mix and the pizza. Why? Well, the trail mix is an example of a mixture and not a solution, since you can separate the nuts and the candies and anything else you put in trail mix back into their own piles. That's why it's a mixture and not a solution. Now I want you to do some show and tell for the people in your house. Share your Tinkercad design and tell them what shapes you used to make your brainstorm idea come to life. You can also teach them about Marie. You can also teach them about what a solution and mixture is. Maybe even ask them what they think a solution is, and then tell them the right answer when they're ready. Questions to think about or questions to tell your families about is what was the hardest part of your design? What was the favorite thing you learned about 3D printing today? We want to thank everyone for coming to another week of our online curriculum and taking the time to walk through our session.